Alright, in this part we're being asked to evaluate. In our first example, we are given an rational exponent or exponential form, 243 being raised to the power of 4 or 5. So let's convert that into radical form. Now, the first form that most of the time is being used is we have 243, my base, raised to the power of 4, and then doing the fifth root. Or the other form, which I'm going to write down here, is the fifth root of 243, and then raising it to the power of 4. Now, the reason I wrote both forms is I'm going to talk about, again, which form is best to use. Now, the first one I wrote, the fifth root of 243 raised to the power of 4. Now, when you're working in this format, the concern is you would have to raise 243 to the 4th power, meaning it's going to be 243 times 243 times 243 times 243. That's going to be a very large number, and the issue is trying to find the fifth root of that large number. So that's going to be a lot of guessing checking. Now again, this format works if you start off with a small number. In this case we didn't, so over here the second format is that we would do the fifth root of 243 first and then raise it to the 4th power. Just like PEMDAS, we're going to work on the inside of the parenthesis and then work with exponent. So we're going to use the second format because it's going to be a lot easier to find the fifth root of 243, which will make a small number, and then you raise it to the 4th power. So the fifth root of 243 is 3, and then after that, now since we have a smaller number, we can raise it to the 4th power, which is 3 times 3 times 3 times 3, and I'm going to write it and expand it out for y'all to see, which will equal to 81. So 243 to the power of 4 over 5 is 81. That's going to be my final answer. And let me box that up. So you're not required to write out both forms, but you can. And then from there, maybe you can determine which form is best to use. In this example, I decided to do the fifth root of 243 to make a small number, which in this case 3, and then raise it to the 4th power, versus you would have done 243 to the 4th power, which will become a large number, and then trying to find the fifth root, which will be almost impossible, or feel like it's going to be impossible. You can do it, but it's going to be a lot of guessing checking. Alright, in our second example, we have 64 to the power of 5 over thirds, or 5 over 3. So let's convert it into radical form. Now the typical one is 64 to the power of 5 being cube rooted. So that's the first form. Now the other form is you're going to do the cube root of 64 first and then raise it to the power of 5. Alright, so let's take a look at the two forms here. Now the first one I wrote is that you would have done 64 to the 5th power, meaning 64 times 64 times 64 times 64 times 64. That will also be a very large number, and then you're going to try to find a cube root of that large number, which is a lot of work. and it's going to feel like impossible to do that. Yet it is still possible, but it's going to be a lot of work. Whereas I wrote the other form, you would do the cube root of 64 first and then raise it to the 5th power. So even though 64 is a smaller number than the first example, if you were to do 64 to the 5th power, that's going to be a very large number. Whereas you can do the cube root of 64 first and then make it a smaller number and then raise it to the 5th power. So the cube root of 64, I'm going to use the second format. So the cube root of 64 is 4. And then we're going to raise it to the 5th power. So 4 to the 5th power is 4 times 4 times 4 times 4 times 4. So when it's 4 to the 5th power, that's going to be 1024. So 64 to the power of 5 over 3 is equal to 1024. And that would be my final answer. In our third example, we have 4 to the power of 3 over 2. So let me write out the two forms, and then we'll talk about which one is best to use. So my base of 4 raised to the power of 3 being square rooted. My denominator is the index of the invisible 2. Now, you don't have to write the invisible 2, but if you like to, go ahead. It doesn't matter. It's just as long as you know that you're working with the square root. Now, the other one will be you're doing the square root of 4 first, and then raising it to the power of 3. Alright, since you start off with a smaller base, either form can actually work, and you can work in either form you like. So let's talk about the first one. So in the inside, you would do 4 to the 3rd power, which will be 64, and then you're just going to do the square root of 64, which is 8. So, it's okay to use the first form because you start off with a smaller base. Raise it up to the power of the exponent inside and then do the root based on your index or the denominator. In this case, 4 to the 3rd became 64, and then I did the square root of it, which is 8. Now the second form is that you do the square root first, which is 2, and then you raise it to the 3rd power, which will become also 8. So either form works because we start off with a smaller base. Most of the time, if you start with a smaller base, you can work with the first form. But if you start off with a high base, it mostly works with the second form. So you, again, smaller base, either form, but you can also mostly work with the first form. But if you have a higher base, usually the second form works most. So either way, it works because we had a small base, and you can see both forms gave out the same answer, which is 8. So 4 to the power of 3 over 2 equals to 8. So that's our final answer. So when you are evaluating, it's sometimes helpful to write out the both forms that I have here to see which one is best to use. Once you identify which form to use, go with that, work it out, evaluate it correctly, meaning follow the rules of exponents and the rules of radical, the rules of root, and then you should be fine. So again, it's okay to write both forms and then deciding which one is best to use to help make your job easier, to make your work easier.